Okay. All right. So thank you everyone for joining us today and welcome to Panoramics of Visions Challenge Me event. So today we are going to be talking about something very important and also maybe a bit touchy, which is exposing the flaws, method transparency. Now, as much as equity, freedom of speech, transparency matters, all of this is nice to talk about. But at the end of the day, I think what is important is that we need to remember that everything has a consequence and every decision has an impact. And where something is gained somewhere, something is also lost. So what I mean is that, as an example, I used to volunteer at Brain Cancer Canada, where equity is everything. Drug cost results in financial loss and strain. And I had an argument with a friend, and he highlighted that when it comes to economics, when it comes to money shifts, where there is a gain in funding, it also means that you have to pull out money from elsewhere. So why am I giving this example? And I think that it's apt, is because it's the very reason why we're having a debate. Perspectives matter. We need to see things from different perspectives, from different vantage points, no matter how true or right or important something is. So this is a topic that matters a lot, we believe, to a lot of people. So I'm going to hand this off to Arpita without wasting any more time because she's the moderator and it is her story that formed the basis of this debate. So I'm handing this off to you, Arpita, and please take it away.
Thank you. Thank you so much. Hi, everyone, and welcome and good morning. So I'm Arpita Kulkarni. I'm a cell and developmental biologist, and I direct the Functional Genomics and Bioinformatics core at Beth Israel Deaconess Medical Center and Harvard Med School. My work really sits at the intersection of single-cell genomics and biological discovery, and I do that at scale for the benefit of the broader scientific community, which means that I end up spending a lot of my time thinking about transparency and reproducibility in science, how we really interpret complex data or high dimensionality data sets like the ones we produce in single cell and spatial omics, and how much we should really be trusting the tools that help us get to these interpretations. So that really is what brings us here today. A few months ago, I woke up and had a thought, and as one sometimes does, I took it to the internet before my morning coffee. So the gist of that post was really simple: that real expertise in the method development space means knowing and both teaching, not just when a method works, but really when it doesn't work. I think that's also a valuable thing to add to our data sets. It just so happened that the incredible team at Panoramics saw that post and they brought all of their creativity and fun to it and decided to turn it into a live and fun debate. So first off, I really want to thank them for inviting me to moderate this conversation. It's absolutely a pleasure to be a part of such a fun and thoughtful event. So here we are. Today, like Shamini mentioned, we are going to be tackling the motion, which is should method developers be required to publish known limitations and failure cases alongside benchmarking results? It's a super nuanced and timely question, one that really sits at the heart of how we build trust and integrity in science. We are very, very lucky to have an absolutely extraordinary panel with us today. We have four brilliant scientists whose work and opinions really shape this field every day. In the interest of time, I'll introduce them very, very briefly, but I really encourage the audience to look them up afterward. Their full body of work and accomplishments is absolutely spectacular and incredibly impressive. Um, so with that, I'll introduce our panel. Speaking for the motion today, we have Dr. Tallulah Andrews, who's an assistant professor at the University of Western Ontario, and she develops computational methods for single-cell and spatial transcriptomics data. Her tools and visualizations are widely used by researchers worldwide, and she's really known for the rigor in questioning how we analyze our single-cell data sets. Next up, we have Dr. Sizun Jiang, who's an assistant professor of medicine at Beth Israel and Harvard Med School, and also an affiliate of the Broad Institute of MIT and Harvard. Sizun's lab really develops new spatial and computational technologies to study viral pathogenesis, tumor biology, and immune dysregulation. Work that's been recognized by HHMI, NIAID, Harvard, the Broad, among many others. Arguing against the motion, today we have Dr. Alissa Greenwald, who's an assistant professor at the University of Toronto and an investigator at Mount Sinai's Lunenfeld Tannenbaum Research Institute. Alissa's work blends computational and experimental approaches to understand how human tumors are organized in space and how that organization can guide more precise treatments. And finally, we have Dr. Benjamin Haibe-Kains, who is a senior scientist at Princess Margaret Cancer Center and also a professor at the University of Toronto. Benjamin leads research in computational pharmacogenomics. He uses AI and large-scale genomic data to accelerate precision oncology and improve patient outcomes. So with that really brief introduction, I'd like to thank the panel for being here today and for sharing your perspectives with all of us. It's an absolute honor to have such an exceptional group with us. So I think now I'll pass things over back to the Panoramics team, and they'll walk us through basically what comes next and officially kick off the debate.
Wonderful. Thank you so much, Arpita, for the introduction. And what I will further do, I'm sharing a link in the Zoom chat for the audience to vote on our motion today. So please take a moment to open it up and vote for or against the motion before our teams deliver their introductory statements. And just for the flow of the event, we would like to start with the pro team. Each team will deliver their opening statements, about 3 minutes each, and then we'll place the teams into the breakout rooms for about 5 minutes, during which time we'll field the questions from the audience. And while the vote is happening, I think we can get started with the first team. So please, the pro team, the floor is yours.
Well, hi everyone, and really thank you for this wonderful opportunity. I'm gonna kickstart the opening statement and hand it over to my teammate Tallulah right after. So my name is Sizun. I want to declare a conflict of interest potentially that Arpita and I are both employed by the same institution. So let's not let the moderators skew us too much. And really, Tallulah, my colleague here, and I are here to argue for the motion that method developers really should be required to publish known limitations. And I really want to emphasize known limitations and failure cases alongside benchmarking results. And really fundamentally at its core, it's not just about transparency. I think transparency is what brought us here, but it's also about scientific integrity, reproducibility, and trust. I think that's really the key word, trust. Where in computational biology, there's a lot of different tools, and how these tools are applied, whether correctly or incorrectly in many cases, can really shape the adequate or inadequate biological interpretations and downstream discoveries. And so if we were to hide where these tools fail, we really risk misleading the entire field of research. And that has happened quite a few times already. And so I think there may be a few key points I want to push out first for everyone's food for thought. Really scientific rigor requires transparency, as we've just talked about.
What do you think tonight? Like, let's play something tonight. No,
apologies. I think there might be a bit of interference here.
like these here, and I'm like,
the host should be able to mute everyone.
Yeah.
And I was like,
I'm trying
okay,
to do that.
the thing, right? I'm like, why aren't you inviting me? And I'm like, oh, it's not a.
Okay.
Great. I'm
yes.
back. You guys can hear me? All right. So in spite of that, the first point, scientific rigor requires transparency. The next is really about educating users, especially people with a slightly different background, maybe slightly less quantitative, or they do not think about some of the aspects, non-computational biologists or statisticians, for example. And this really allows us to build, both rigor and defense against misapplication. I think that's really a key here. The third is actually, it goes a little bit deeper to us as a community, which is the idea of cultural change and incentives. we all want to publish in these glamorous journals. And of course, I'm a victim of that as much as everyone here is. And so there's often this fear for if we were to show limitations, we are going to shoot ourselves in the foot with these methods. And I really think that's something we need to change as a team. And finally, is long-term trust and reproducibility. And I'm going to pass it on to Tallulah in the last 40 seconds to have any add-ons.
Sure, I will echo most of those sentiments, and I think the point about trust is the key one here, where it's not just whether they trust our methods to perform well, but also trust their results from it, right? Where bioinformatics is now becoming widespread, not just in academic research, but also in clinical trial research. And if we're going to ask Health Canada or patients to trust the results they're getting from our tools, we have to know and be open about where the failure points are and how we're mitigating around those. And it's really getting to the point where that is where some of these methods are going. So we have to be prepared for that.
Shamini, could we give them another 10 seconds? I think there was a little bit of,
Sure.
yeah.
That's
Tallulah,
it.
if you want to go ahead and add something else, we didn't want to cut you off.
Sure. Yeah. Yeah. And so it's not just for in the clinic, this is critically important, but also among wet lab experimentalists who are generating this data. Lots of them are trying to use our tools and they don't have the skills to evaluate computationally whether they work or not. They don't have the time to test them whether they work or not. So they need to be able to trust that our papers are honest about whether they do or don't work and when they do and don't work so that they use the right one for their data and don't submit their paper and then the reviewers come back and say, oh, you have to redo the whole analysis because you did it wrong. Yeah, so it's really about trust at all levels.
Thank you so much for the pro team. Now the con team against the motion will deliver their opening statement.
Yeah, thank you very much. Great way to kick off the debate. I'll have the honor to kind of do the introductory statements, and then Alissa will do the closing statements. So I really appreciate this focus on trust and transparency and rigor. But as our host basically said at the very beginning, everything has a cost. So I would argue that sometimes you don't really need to be that transparent. If you just describe very well in your paper, your methods, your data, and your results, that might be enough for other groups to kind of either trust or even reproduce the results. Very often we design studies that are really specific in nature, and we kind of need the community to anyway reproduce some of those results using slightly different context to really prove that that a result is generalizable. And at the end of the day, if you put a very high requirement on what people need to do in their studies, such as intensive benchmarkings and look at a lot of failure cases and share all the assets such as code and data, what's going to happen is that it's going to slow down scientific progress for multiple reasons. One, it's a lot of work and we don't always have the resources to do all those things. Second, it could put career at risk. It's very hard to publish in Nature if you have an extensive list of limitations. Reviewers are very sensitive. They're going to look for anything that may sound a little bit negative about your study to reject your paper. So there's a real risk that you're going to be prevented from actually publishing your results. And as I said, there is a need anyway for the community to explore how your results are generalizable. So it's not only the responsibility of the authors, but it's actually very important that independent groups are doing it anyway. So putting too much requirements at the very beginning on the authors is going to put a lot of pressure on them. Another aspect is that it's going to threatens commercialization and translation. If you disclose too much about the methods, especially the failure cases and the code and the data, you may actually be prevented from pushing a product and commercializing, and it's going to generate a competitive disadvantage for the original authors. Another aspect is that if you disclose too much about your approach, you actually people could just misunderstand the failure cases and still misuse the product of your research and potentially cause patient harms if you work in healthcare. Sometimes sharing too much is also creating a risk for privacy and security. So you have to be very careful about what you're sharing. And there is definitely a culture shift that needs to happen, and that is a very long process, and it's kind of hard for authors to be responsible for such a culture shift. So I'll stop there.
Yeah, Alissa, if you want to chime in.
It would be unfair at this point. Sorry, Lisa.
I'll chime in for the closing.
Okay, wonderful. So now we would like to place our teams into the breakout room so they can discuss their rebuttal strategy. During that time, we will welcome the audience to ask their questions, and I'll just share the joining instructions for Slido in the chat. Thank you.
I'm assigning now, and then I will stop the breakout room in 5 minutes.
Sounds great. Thank you.
So do just the panelists go into the breakout rooms?
Yeah.
Yeah, cool.
So the panelists are now in the breakout room so they can discuss their strategy. And the audience, please feel free to rank the questions using the link that I have shared, as well as please ask any questions there that you might have as well. And just to announce the pre-debate vote results, we are for the motion so far. Let's see if that changes after the debate. And thank you, Arpita, for kicking off a little icebreaker. If everyone can also share where they're from, where are you joining us from today? Please let us know. I am in Toronto myself as well.
Awesome. There's obviously no pressure. So whoever wants to share is free to share.
Thank you for participating. Please rank the questions, but if we have time, we'll address the ones that have more votes first. You can also type your own question.
Okay, so I just took a sneak peek at both the teams in their breakout room, very furiously discussing. Please furiously think of questions to get back at them when they come back.
Let's say the team arguing against the motion has it's a rather difficult, not an envious position, I would say.
Yeah, it's a difficult topic. I mean, ideally, in an ideal world, you would want everything to be fair and everything documented. But reality is very different. Being practical is another thing altogether. And then getting documentation done is another whole thing as well, right? Yeah.
Absolutely.
Maybe you can share the original post that you posted that actually kickstarted this. Did I miss that? Maybe we can share the link to that post, Arpita.
Yeah, absolutely. Um, or if people want to just find me on LinkedIn, that might be an easy way to just go read that thing. I mean, it really isn't such a original idea, right? The panelists that we have, including Benjamin, has been a very strong supporter for the idea and the notion that we need more transparency and we need more rigor when we publish these methods and these data sets. So definitely wasn't the most original of ideas. Nothing was said that was absolutely groundbreaking. But I think what really resonated with people was the fact that maybe the conversation kick-started the discussion around how do you balance the realities of being a scientist in today's world where there are metrics to be reached. You want to publish in the highest of journals and you want the credit of the work to go to you. And sometimes in that tough, it's like it's a razor's edge. You have to make certain decisions in order to reach certain outcomes, and then how do those outcomes really, what are the consequences of the decisions that you make? And I guess even though we've framed today's discussion as a debate, it's really just like Shamini introduced at the beginning. It's just for all of us as a scientific community to come together. And I don't even see it as a disagreement, but a healthy disagreement of sorts, since just shedding light from the experts who've been doing this and publishing these type of data sets, and just letting us know why they make the decisions that they make. So it's really just a masterclass and a learning exercise more than anything else. I see that their time is about to be up, so we'll just wait for the panel to come back.
Yeah. So I've shared the original post just to let everyone know. Sorry, go ahead.
No, that's
Yes. So it's one thing to think about things, but it's another thing when you think about call for action, right? So you want to drive a change, then you have to have a call for action. And yes, as Nicole just wrote there, a necessary discussion. You don't start discussions, we cannot have actions. Yeah. So we have 6 seconds. Do we bring them out of the breakout room? Shall we give them or no? We bring them out. Yeah. I think it's enough. So let me close all rooms and they will return in 60 seconds. So you have 60 seconds to chat actually. So think about this. Think about the questions you want to ask. This is the moment where we really want to test the system. We want to push the systems. It's easy to have an ideology, but to take the steps to actually execute so that it leads to action is a totally different thing, because we live in a real world. We're going to meet with resistance. So the pros and cons, they are two different vantage points. And I think in any kind of decision making, it's necessary to think of all these things in perspective, especially when we are scientists and everything that we do does have an impact. in the real world. All right, I think they should be coming back anytime soon. Yep, they're coming back. Is everyone is back? Yeah,
Can I
Alyona, I
just
think
say the timer in the Zoom window is very ominous. It's my first time seeing it, and it reminds me of a horror movie.
yeah, it does. I don't like it very much, but it's good for debates.
Hey, thank you so much. So I hope you had some time to discuss your strategies. Now we can have each side address the other's arguments so you can reinforce the position. Any preference? Anyone feels really strong about starting first?
Sizun, Tallulah, the floor is yours.
I've been nominated. Okay. So I'll address a couple of the points brought up by the other side. So the first one's resource limitation, which of course everyone is feeling the pinch of resource limitation. That's just a fact of life of research in Canada. But in terms of resources, what we do is actually the least resource intensive step in the research enterprise. Right? Most of us can get by with a couple of students, a couple of computers. We have free high performance computing already. Like, if we're going to have a resource limitation, it's not with us, I don't think. I think it's with the experimentalists, the people out there fighting for their 17% chance of a CIHR. It's out there at the clinical trials where they're battling for a handful of dollars from clinical trial companies. So we should have the responsibility to make sure our step is as accurate as possible so that resources aren't getting wasted at these other steps later down the line, which are much more expensive. And also with publishing in top journals, we all know publishing is a mess, especially in top journals. And there's lots of things that go in there, politicking, that is sort of aside from this. But it's also bad for those journals to have methods that are incorrect or that are not going to give people good results to be published in those journals. And if we do sneak things in and get them published in those top journals and they prove to be wrong later, that causes a whole scandal for us, it causes a whole scandal for that journal, and it tarnishes the reputation of that whole journal and that whole field. Because the bigger profile something is, the bigger profile it will be when that's proven to be wrong. Right? And then that will tarnish the entire field. So sure, we would all love to publish in top journals, but we shouldn't be glossing over our own limitations in order to do that. Because it will ruin our reputations, it will start tarnishing our field's reputation, and it will further tarnish the reputation of those top journals, which is not good for anyone. And I'll pass on to my partner.
Thank you, Tallulah. And I think really, I'm just gonna very briefly summarize the gist of what we're gonna be pushing for, which is short-term benefits versus long-term gains. And I think if we were to not extensively discuss and explore the limitations of different methods, we're gonna shoot ourselves in the foot as a community in terms of commercialization, where, as much as people want to get it done fast, they want the right answers. If in any kind of commercial entity, if it's making a drug, for example, and we've all seen examples of drugs and blood testing companies that have failed tremendously. And that has massive repercussions to the entire field because the lack of trust needs to be regained. And that is the long-term losses that we're going to face if we choose to go for short-term benefits. And so with that, just keep in mind, and I'm excited to hear what our colleagues have to say.
So should we start the rebuttal side?
Yeah, absolutely. Go for it.
Okay, so we thought kind of a common theme was, the importance of trust and integrity. And we want to argue that people can't really accurately assess trust and integrity. And in fact, I mean, oftentimes people sort of just produce tremendous volume of, supplemental figures and just like really an onslaught of data, with the idea that just by overwhelming and flooding us with data and information, that this is transparency. Oftentimes, this can just be a ploy. Like there's sort of a false sense that if someone discloses huge, vast amounts of information, that it's relevant information. Oftentimes it's too much information to even properly assess. And then we would also argue and that, true robustness and reproducibility in many ways is the ability to come to the same biological conclusion using multiple or orthogonal approaches. And so just to be able to reproduce the same analysis with the same method and the same result start to finish is actually kind of less convincing in terms of robustness than multiple approaches that reach the same biological conclusion.
Maybe I can follow up on that, saying that trust is probably an illusion. As a scientist, I don't use trust in my work. I actually never trust anybody, including myself and my own lab members. So it's very important that we have quantitative evidence that a result is robust enough. And there is nothing more, as Alissa said, there is nothing better than this, than independent groups trying something slightly different and basically draw the same conclusions and observe the same results. I think that's the highest bar in science, and trusting the integrity of the initial authors is probably irrelevant for scientific progress. I would also argue that journals, even though they have beautiful policies that are very much aligning with the principles of open science and transparency and reproducibility, they are more often violated than not. And there is a very, very simple reason for that. 90% of the journals are for profit, including the magazines such as Nature, Cell, Science, New England. Their only incentive is to make money. They have to generate revenue. They're not here to help science progress. That's another illusion that scientists really needs to forget. We created that system. We work for free. We peer review those papers. We put our careers on the line on the reputation of those papers. These papers are generating billions of revenues, actually probably more lucrative than drug dealing. So you cannot trust journals to be the scientific the moral compass or the integrity compass for science. So I would rather actually publish on a preprint server or non-for-profit journal than Nature, Cell, or Science if you really care about integrity. And the last
given the amount of time, I'm sorry, I'm gonna butt in here as the rebuttal, that I feel like this conversation is taking a detour away from the main point that method developers are required to publish or show known limitations in failure cases. I think that would be independent of the journal that you choose to publish in, including preprint servers. And so I think that will be a very interesting discussion for a future conversation, but a sidetrack. The other element that I think we're getting towards too is orthogonal validation. And it comes back to, again, the whole concept of trust that we've been talking about. And I think this is really exciting because it sounds like you guys are also in support of our motion here, which is we need to build the trust together as a community. I think, we've all been developing methods over the years where we show these are the stats that we outperform everyone else, but certainly we all know what are the best use cases and not the best ideal cases from just being able to use it and being the first people to use it. And I think that's the motion we're pushing for here, that we need to discuss them. And I think exactly to your point too, Ben, that journals, they need to make money, but they also have a reputation to upkeep, as Tallulah, my colleague, has been alluding to. They don't want to publish papers just to make money and long-term people decide, hey, Nature doesn't seem like the journal we should trust anymore. But instead, why don't we focus on the whole concept here? And I think we wanted to take the pace up a little bit. It seems like the audience is responding well. But we should focus on, do we need to tell people that, hey man, this thing works well for 90% of the cases, but there are these edge cases we just want to talk about. So for those of you who publish in the Cell Press journals, you are required to put a whole paragraph of limitations of study, whether or not it's a methods, whether or not it is a biological interpretation. I think orthogonal validation that has been brought up by Alissa is wonderful, and that's really what we need. But ultimately, we ourselves have to be honest in our journals, even if there's 100 supplemental figures that we often are asked to make. And I'll be honest here, most people may not read them, but there are this 1% occasion that probably you guys have felt, because I've done it before, where you dig into supplementary figure 66b, and that's exactly the thing that you were looking for, because somehow someone asked to do it, nobody else cares about it, but you do, right? And because of that, I think that's a little bit of incremental movement that we want to do together as a community.
Alissa, you want to respond to this?
Am I unmuted? Yeah, I mean, so I, agree with many of those arguments, but I also think that at the end of the day, like, it's a two-way street. And, the scientific community really needs to be fully engaged in this process. And it's not just the obligation of method developers to exhaustively disclose every possible use case, especially when, they often developed a method to address a really specific biological question in a specific context. And so I think that the community also, has a responsibility to test and engage and report back their findings, and the onus really should not lie exclusively on method developers to do that.
And I
But
think that's exactly the point. The onus doesn't just exclusively lie on the developers, but I think as developers, we are not pushing away that burden entirely. I think that Tallulah is probably more to add on this, that it's about being part of the community where we say, this is the 5 edge cases we tried before. We're going to be honest. It doesn't really work well here. And probably the community can find another 100 more edge cases.
I think I'll be the cynical in the room saying that if you ever oh, sorry, go ahead, Tallulah.
And I would add to that why should we as method developers be held at a lower standard than the experimentalists? Experimentalists have to include positive and negative controls. Lots of methods papers don't include negative controls. They only include positive ones. Why do we have a lower standard for us than I would have for a genetic knockout experiment?
I'll be the cynical in the room saying that if you ever put proper limitation in this limitation section of your paper, or your grant, by the way, the risk of being rejected is much higher. And so the game is to put enough limitation so it sounds like you look at it, when in reality, you didn't really properly put the real limitations there. You didn't put the real negative control that failed or the positive control that failed. A lot of those stories have been manufactured to look really fantastic. When you do experiment on 10 mice and you only reported 2 that worked, you'll never know as a reader, but it's a failure of the scientific process. And I disagree with Jono. I think there is no bad publicity. We've seen a lot of studies have looked at the reproducibility of papers, and Nature Cell Science are not at the top of reproducibility. On the contrary. So I don't think that's the valid argument. We should not rely on journals to really move science forward using their policy.
But I think we're arguing that we're not relying on journals. We haven't mentioned that part. What we are relying on is ourselves as the method developers, that we are transparent with the community about what works and what doesn't. We are not, of course, doing an extensive grid search on what is the likely, every single possible failures. But I think we just need to be very honest and upfront about what doesn't work. And I completely agree with you, Ben. There are these grantsmanships and also, journal politics that we try to go around in terms of limitations and fail cases. But I'll be honest, having a relatively limited lifespan of reviewing grants and journals, usually the really obvious caveats are pretty obvious to most reviewers, and when they're not discussed, there's usually someone will point out the elephant in the room, usually me. But I think we also have to have some faith in each other as part of this community, and coming back to the whole idea of trust again. So I think, I really like the points that are being brought up here. I think it's actually growing much bigger than the original proposed motion. So we're gonna blame Arpita for really not drinking her coffee that morning. But it does seem like there is a number of different things in terms of who the stakeholders are, right? And as scientists, as much as I'm gonna come here and pretend like all I care about is getting the science right, and I do, but that's only 20% of my job, and I think all of you can resonate. The other parts of it is too, like, how do I ensure continued resources for the lab to try to answer that 20% of getting the science right? And that is a huge other portion. How do we get the trainees to the next stage? And so I think it becomes a lot more difficult than this sort of very philosophical question that we are tasked to do. And there's no 100% on one way or 100% on the other. But I'm rather curious about how we're going to come to a balance in the end. And I'm really going to be posing these questions first to you guys and then to the audience.
And I would just add that the sickness of the publication system in science is really, I think, the virus in the heart of science that could destroy us forever, right? Because we rely on the taxpayers to pay for our research. They pay for our students. They pay for the computers we use. If they find out that we're using that money to play games, to publish in high top-tier journals without doing the proper work, lying or cheating or hiding things because it helps our career rather than doing the work that benefits the taxpayers who are paying us to do this, what are they going to think? Are they going to continue to give us money? We have an obligation to be using their money responsibly.
Alissa, I have another bad faith argument, but I'll let you go first.
I mean, to that, I would say that I think that we can all agree, right, that scientific misconduct, intentionally lying or cheating in order, to gain journal acceptance, that's absolutely unacceptable and it's bad. To me, the more relevant practical question is about the cost, both in terms of time and resources, for more stringent documentation of failure cases, and that sort of obligation of the method developer to do that versus our ability to devote that time and resources, towards continuing to innovate and push science forward. Like there's a clear balance between what we sort of invest in all the proper documentation and just continuing in good faith, and continuing to innovate and develop. And so to me, like that's the more practical cost benefit rather than, the issue of whether we're intentionally lying or cheating, which I think everyone on either side can agree is unacceptable.
I would argue that why changing a system that works? We keep publishing in these big journals. We don't go too deep into the limitations of our methods. We innovate, we move forward, we don't look back. And it worked for us so far. So I don't really see why we should change a system that works so well.
Yeah, I mean, I like that point. And Ben, this is great. If it ain't broke, why are we trying to fix it? Well, I think speaking of someone, by the way, I spend a lot of my time in Toronto because my wife's from there, so I feel like the honorary Canadian here. But in the US, we're seeing a very different climate from the rest of the world, given what's happening right now. And if we come back to, again, the fundamental question of trust, and I think that's really the underlying thing that is being discussed, how much do we need in terms of resources to build that trust? Method developers, you have a method, how much do you want people to trust that your method's going to work and your results are always going to be what they are going to be claiming they're saying. And I think that's really a point around communication of the results and trust that is underlying here, where, again, this is extrapolating to what's going on in the United States now, where there is a failure of proper communication across the broader community in terms of scientific trust that is a huge result of this divided nation at the moment. And sorry for going to politics. This is sort of, I promise that there's an end game here. But if we think about now in the smaller world that we are as scientists in our communities, if people can't trust our results, right? And whether or not we publish in a journal, I think we all know is one thing. There are certainly journals and certain papers in top tier avenues that we do not trust, and certain authors that have built a reputation that we do not trust. And then now coming back to this, how do we then build a reputation that is trustworthy? And I think part of that, as methods developer now, we went from something very big to something a lot smaller, is that we just need to be very open and forthcoming with what works and what doesn't work. And I think this is really where we need to think about more as a community.
Absolutely. Thank you for all of those super interesting perspectives. Aliona, do you want to move us forward?
Yes, absolutely. Thank you so much. I think we can now address some of the questions. I will share the link just one more time so the participants and the teams can have access as well. And I suggest that we go in the order, starting from the questions that rank the highest. And again, please, each team feel free to explain your side of the story from the perspective against or for which you're arguing. So the first question is, how can the review process be adjusted to reward transparency rather than punish it? Any thoughts from any of the teams?
So I said all the bad things about journals. For instance, media communication has a very nice process where the reviews are being published with the paper, which I think is a fantastic way to augment the papers. Some journals offer non-anonymous reviews, but it's a hot topic. I don't care because at my stage, I don't really care about having more enemies, but when you're early career, it really matters a lot. So I understand why people would not attach their name to a review. However, when you do, you're more accountable about what you say. And so you probably want to put a very high quality review out there. So I think improving peer review is difficult, but there are ways. And I would argue that we're often talking about pre-publication review. I would love to see some post-publication review. Convincing 3 to 4 random folks, not really random, let's say expert in the field, that your study is good is one thing. Convincing the entire community is a lot harder. And other research fields such as mathematics have a very, very different approach to peer review. And I think we should take some inspiration for all the genomics and health-related research we do.
I agree completely with Ben. I think that it's really important to not sort of end the discussion at the time of publication. I think that, the way things currently work now, I think preprints are wonderful. That's sort of an awesome exercise in open scientific communication and sort of having the community vet something. But if we could even continue that conversation and that process post-publication, rather than the publication itself representing the final endpoint, then I think that that would be extremely constructive and helpful, especially with regard to the things we're discussing today in terms of sort of continuing the discussion around limitations post-publication, and really giving the scientific community a way to engage in that conversation. I mean, even if the journal would sort of host an open discussion or comments section associated with each paper, I think that would be great.
Yeah, Ben, Alissa, I think these are really awesome points. I think there two things I'm seeing that I'm hoping will bring us forward together even more. The first is sort of this point I think, Alissa, you're alluding to, of being a sort of a life, almost like a life, like a paper should be something alive, right? That we can constantly build upon, we have discussions about, and it's almost like a GitHub or some kind of repository that you can see all the different commits and tracks over time. Would love to see some form of that. I think some folks were trying to do it, but I don't think it's really taken effect yet. But the other is sort of, it lies on the onus of the journals. And I think one prime example is that we're seeing in both eLife and Nature Methods recently. And eLife has this whole review preprint, which I think is great, and for many other reasons, even though it's not fully taken flight. But they both have recently pushed out this idea of a registered report, which I really enjoy, because essentially what it's asking for is give us one figure of something that you're trying to, I'm going to give an example, benchmark or test a method against, and it's going to be sent out for peer review. It comes back whether peer reviewers are going to say, I want these 5,000 other conditions, right? I'm just making up numbers here. But the best part is once it goes past this stage, it doesn't change anymore. The reviewers can shift the goalpost, which has happened to all of us. Once they've agreed that this is the conditions that you're going to go test, your paper is accepted at this stage, you go out and test all 5,000 conditions, and you come back and say, look, these are the ones that work great. These are ones that have failed. But you know what? The paper is already guaranteed to be out, and this is a way to really enforce this slight detachment of being associated to, you must be the best method to be published in the journal. And I'm hoping to see more of that example.
Yeah, I can agree with most of what's been said. The publishing the reviews is really nice. What I would love to see, but I don't think will ever happen, would be that journals that publish methods are required to also accept or all journals would be required to accept papers that directly try to reproduce that paper in that same journal. So there's much more incentive to try to reproduce things, because right now, like 10% of things get reproduced. Because there's no incentive to do it, because you can't it's really hard to publish a paper just reproducing or finding a hole in someone else's method. It ends up in a low-tier journal, it's a ton of work, very little reward. Whereas if we could say, no, journals, you're required to publish also anyone trying to reproduce it, or anyone who finds a serious problem with it, now there's at least more reward and more incentive for people to do that orthogonal replication.
So Nature Machine Intelligence has a new article titled Reusability Report, which is very visionary and kind of aligned well with what you just said, except that they don't want just reproducibility. To Alissa's point, they want you to go beyond. They want you to reuse the methods in new context to potentially show great performance or limitations. And I think that resonates very well with what you just said. The other thing that's a little bit upsetting with the current system, which I say ain't broken, but still is broken in many ways. Journal editors don't accept rebuttal very easily. A lot of them are just rejected, which basically prevent any proper scientific exchange on a given paper. Because you made excellent point that a paper is a living entity. It should not just stop at the publication. But how do you make it a living entity if there is no way that it can actually share concerns or optimism about a paper? Yeah, if I test a data set and a method on a new data set and it works, I would love to be able to publish a letter about this. So everybody wins, the authors, myself, but journals don't see that as probably a way to attract a lot of citation. I don't really understand the reason why editors tend to reject 90% of those letters, but I think if we publish more of those, we could really have a lively discussion and make those papers a bit more interesting long-term.
Wonderful. Thank you so much for all these perspectives. And the next question we can discuss is whether journals should mandate a known limitations section for method papers. Also a topic that has already came up today.
Yeah, I can mention it since we brought it up from our side. I think there are journals that already have them, and it's required. And completely agree, Ben. Very often you can see certain groups just check the box with some comments in there, and then hopefully there are other groups that take it a lot more seriously. I think, mandating is one thing, whether or not people follow it with the real intentions that were intended is a separate one. So I think that's a whole different other can of worms.
I wonder about the possibility of requiring a limitations section that only is written after a decision is made about the paper. So I think that that would really encourage people to be more open about limitations in good faith if they know that it will not negatively impact the review decision.
Yeah, I love this discussion about removing yourself from the actual result. And I think it's, you actually talked about pre-register review reports. I didn't know that concept. It's fantastic. But it was also the concept that we use in clinical trial where you pre-register your analysis, which also reduce the risk of artifactual discoveries just by trying again dramatically. And trials, things are so high stakes that it's required, but in research, we don't really do that very often. A mild form of pre-register analysis is kind of those open computations where you fix the input, you fix the test set, you fix the matrix, but you don't really fix the method, so people play with the methods. So I really like this idea of writing the limitations and maybe put a little bit more structure around what needs to be done so that the science is more robust, but why not preventing publication because the results might be negative? I really like this idea of maybe making it a post-decision about the paper so that whatever the results, you feel really at ease to share all of them.
Yeah, but making it as a post-decision thing might work, but to a large extent, I think we can't put this on the journals, especially the journals in their current state, because they don't really have an incentive to back it up with anything and really enforce it. I think it really comes down to how we train our graduate students, and we need to train our graduate students to be good reviewers who ask for this. Because I think I don't know. I'd love it if the journals were good and enforce this stuff, but I don't trust the journals anymore to actually enforce this.
Thank you for the perspective. Let's address one more question. How would method developers present their unsuccessful cases on a publication level? How can this look like in a researcher's day-to-day life?
So I've done this for one of my methods where we put it in the supplementary and put a note in the discussion of, hey, we tried it in a bunch of these other cases other than what we showed in the results. It kind of worked, or maybe it didn't work that well, and then directed them to the supplementary. It's not, I don't know if that's the ideal case. I like that for sort of niche cases where it's like, this isn't something everyone's going to do, but you might want to try this. Hey, we tried it. It didn't really work. Whereas for other cases that are sort of the main use of the method, I'm always in favor in all when I review things that you have to show me a positive control and a negative control, just like any other experiment would. So show me those in the main text. If you want, edge cases can go in the supplementary, but they should be there, ideally.
Anyone else want to pitch in on that?
Hey. Does anyone have a personal story? Can someone give a concrete example of a time when a method you developed or used failed and what you learned from that failure?
I can share one of those. That's highly relevant to this area, in that we tried monocle 3 on the malaria cell atlas. And so the malaria set, this was a data set where it's the life cycle of the malaria parasite, so it's like a circle. And you can see the beautiful circle in the PCA. We ran monocle 3 on it, and it turned into this weird, like, caterpillar-shaped thing after running monocle 3 on it. And after that, I've been telling everyone at every opportunity to never use monocle 3. But it's one of those things, like, could I publish that? Probably not. We didn't put it in the paper for that data set. It's just been part of my teaching slides, and whenever I'm talking to people, I tell them about it. But I don't know if that's something I could have published or not.
Yeah, maybe I have a slightly different example. There was a couple of Nature papers looking at cell lines, and my team decided to kind of compare those papers. We waited for a long time for the broad and the Wellcome Trust to do it, but nothing really came. So we decided to kind of look at the data, compare the data, and we made everything available, the codes, our process data sets, and everything. We got lucky enough to have actually an editor who accepted it because it was kind of a Robert tool. And obviously both the broad and the Wellcome Trust were very, very unhappy because we showed that the data were not very consistent between the two big studies. And two things happened. One is that because we shared everything, we felt very comfortable and we answered quite efficiently all the critiques that we received. So that's number one. So transparency could be used as a shield as well, saying, look, I may have made a mistake, but because everything is open, I'm acting in good faith, right? And actually, a lot of those critiques, we could just say, look at the GitHub repo, line 294, you're wrong. But sometimes people were right. And we actually made quite a big mistake in that paper. And we corrected it. Luckily, it didn't change the conclusion of the paper. It was a big mistake nonetheless. And so we contacted Nature and said, can we correct it? Or can we, actually, we had a completely updated analysis because all the critiques, actually, scientists recommended better approaches. So we adopted those approaches. We looked at more data, et cetera. And we told Nature, can we publish that? It could be a corrigendum, could be a new paper. We don't care, right? It doesn't have to be on PubMed. We just want to make sure that people have access to the latest results with the best approaches. They refused, right? So we had to basically go to F1000 research and publish it there. And the visibility is very low, right? But the point is, one, transparency was good for the survival of our team in a way. Second, we made mistakes and we corrected them. Third, there was no obvious way to attach those corrections / updates to the original paper, which I think is a proof that the system needs to be improved.
Yeah, I have an example along these lines too. We had this is many years ago now. We had a cute little method that we wrote during the pandemic that was for a very niche use case, we thought at that time, and it turns out people were thinking about this problem a lot. And so we originally wrote the code in MATLAB because that was, again, it was a very rushed one-time side project that we ended up realizing if people want to use it, they should. And the nice thing was actually, subsequently, of course, we realized not everyone wants to run MATLAB, and I myself being one of them now. So we converted the code base to Python, and we had a little bug in there. But what was really amazing was there was a big community effort at that time from the HotMap and H10, and they were benchmarking as part of hackathons some of these methods for both reproducibility, usability, but also does it really work, which might come to some of the other points that we can do as a community. And so the amazing thing was, first they found a bug in the Python code that it didn't affect most of the output, but it was great that they did. And the second was they Dockerized the whole thing, so it was so much easier for others to deploy them at scale now. And it was just amazing to see. And of course, then they did the benchmarking, they found what was good and also what were additional limitations that we either knew or we didn't know about. And it was really great to see that, there are people who think about this problem and maybe even build on top of it. And, our both ability to contribute, but also errors that were corrected as part of the self-correcting scientific movement was just really heartening to see.
Thank you so much for sharing your personal stories. I think that failures in science is part of our daily life. And I would say there's probably more failures that we face than there is successes, but that's how we learn. That's why we do science. I think that's the only way we can move forward. That's why this discussion that we're having today is greatly important. And I would like to address one more question from the audience. I think it came from Alissa, who asked she asked who should own the evaluation of a particular newly developed method or area of research. She wonders if it's time for a total overhaul of the peer review process. I'll add the question in the chat as well for easier access. If anyone has any thoughts or would like to contribute, please let us know.
I would say ideally it should be the developer. If you develop something, or if you do some novel research, it's your responsibility to make sure that is correct, right? We won't say an experimentalist who discovered, oh, we think this drug cures cancer, oh, it doesn't. Well, is that the reviewer's fault? No, that's the person who did that original research holds that responsibility. So should the developer of new methods. But obviously, science is a collaborative effort, or it should be. I don't know how much it still reaches that goal, but that was always the ideal of science. So the community should also be taking some ownership of it and to test these things. But I don't know.
Yeah, it's definitely a shared responsibility. I think authors need to own and be responsible for their work. The community, but it has to be done in a way that the community can easily build upon any piece of work. And actually, Sizun's example is great. Like the initial study was interesting enough for people to invest in it, make it better. We cannot hope for anything better than this. Like we build upon others' work. And so if somebody wants to fork one of my packages and making it much better, they should get the credit for all the improvements, right? And I think in a way, sometimes I'm a bit afraid that people think like, oh, it's my thing, therefore any derivative I should be involved in any derivative. I think that's very damaging for science. It was your thing until you made it public and communicated about this. No, it's a thing from mankind, and anybody can kind of build upon it. So I totally agree with you, Tallulah. I think, but some people think about this a little bit differently, and they think about it in terms of control. It's my thing, and that's why they don't put open source license and that kind of stuff. And I think that's very damaging. But all universities want to generate revenue and commercialize, so those things happen.
Yeah, I would agree with that too. There's a difference between owning the result and owning the product. Once you put it out there, others should be able to build on it. Although I will say, as someone who's had things reused and not been cited by those people who reused it, it would be nice if you at least cited who you borrowed something from. But yeah, people should be able to reuse stuff. Once you've published it, it's there for everyone to build on.
But even if they didn't cite, it's still good for science. Not as good as it would be for you, but it's still good for science. So I think we have to take a step back and distance ourselves from our own product. Like, we've been paid by taxpayer money to do this. We had a lot of fun and passion doing this. So you can just give it to mankind and see what happens. And if people do the right thing, you're gonna get a lot of credit for this. But it's not. If you think about that first, then it's very damaging. And I think some people do, not the new generation. I think the new generation has been raised with the principle of open science, and culture is changing, but it's slow.
Yeah, thank you. Thank you so much for those rich perspectives. Aliona, in the interest of time, do we want to first see how the audience has voted on the motion, and then we can take it forward from there?
Yeah, I think we can move forward. Thank you so much for addressing all those important questions. There's definitely a lot more to discuss and address, but we would like to move on to the discussion of closing statements. So I would ask Shamini to please help me move the participants into the breakout rooms so they can discuss their closing statements. You'll have about 5 minutes, and then you can deliver your approximately 3-minute closing statement, after which we'll have the audience vote again to see whether anything has changed from the first vote.
Okay, so shifting everyone to the breakout rooms now.
Thank you. And while we wait for our participants, if the audience has any more questions for us, maybe our team and Arpita can address them as well. We try to cover as many as possible. There's lots of great questions. So if there is something that we haven't talked about yet, let's discuss it now. We have about 5 minutes or so.
This could even include things like ideas for future events. As people working in the single cell community, if there are pressing issues that you'd like experts to come and address, I think this would be a great time to leave a note for Aliona and Shamini.
Yes, absolutely. And we always welcome feedback on our events. We will share a post-event survey afterwards as well. So if you don't want to share it now, you're also welcome to do so anonymously afterwards to help us improve and make sure we have smoother events in the future. I think one of the questions that we also had from the team that we haven't yet addressed was how we can incentivize method developers to publish negative results and limitations. There is no reason to disclose limitations, or what was tried to make it work.
Sorry, Aliona, can you repeat the question again?
Yes, I can add it in the chat as well. How can we incentivize method developers to publish negative results and limitations? Thank you.
Anyone?
I guess my 2 cents on that is I have very limited experience, but assuming, supposing I was running a company, for the sake of this argument, for example, 10x or Visgen, I was running a platform and I was offering these services to the community. One of the biggest incentives would be to help build trust with my customers and with the community in general. So I would see being open in discussing the limitations and possible cases where a technology or a platform might not work. I would see that as a strength, putting that out there for the community upfront as a strength in helping build trust in me and my products and my company in general. Because, the thing is that everyone eventually finds out the loopholes anyway. Nothing remains hidden, especially if you're trying to develop something that's, top class and you want everyone in the world to use it. Chances are that the huge community gets mobilized and they want to try this new exciting technology and a new exciting platform. And then if the feedback in the community is people just bad mouthing you, saying that, hey, this is, it's not worth the hype, or it doesn't really deliver, or it fails in 100 of these scenarios, then that's a bigger issue and a bigger problem. So I think the biggest incentive is building trust in your product and yourself as a brand. People are starting to trickle back.
Not yet, but soon. I'm gonna close it soon.
1 more minute, I see.
And yeah, they will have now 60 seconds to return back. And they will have the ominous timer on the.
And the red flashlights.
Yeah. Oh, actually, one team is already back.
Yeah, I
we
can
just
see
want to
it.
see what you guys are doing.
Yeah, we were actually discussing, we'd love your take on this. We were discussing one last question that we thought was super interesting, which was how can we really incentivize method developers to publish negative results and limitations? Is there a reason that no one's disclosing these limitations, and what has been tried to make it work?
Yeah, I think it sounds like it's linked to some of the earlier discussions, like Tallulah was putting it into the supplement, or whether or not you can discuss them after the paper is accepted. I think that helps at least lessen the burden on the fear of risks involved.
Okay, everyone is back.
All right, thank you for that perspective. Great question. We will now have both teams deliver their closing statements. Each team summarizes their stance and delivers final persuasive appeal for about 3 minutes. Any preference on who would like to go first?
Alissa, maybe we can go first this time.
Okay.
Sounds great, thank you.
Yeah, so I mean, in conclusion, we really believe that this motion, that disclosure of use cases, will really improve transparency in science, and that it's an obligation. We feel that this is, very much about the scientist and not the science itself. And that ultimately I can report to you anything, that I want about what I perceive the limitations to be, or the edge cases, or the correct application. But that's really, about me as an individual. And again, appealing towards this sort of emotional issue of trust and integrity in the scientific community. But really, I mean, the objective information is, the code and the results that I can give you, and the obligation, it's really a two-way conversation. And the way to really properly assess my science is by taking my methods and my results and testing them yourself. And so we really can't replace, the community taking an active role in that. And just in general, we believe that a big issue in science now is sort of people are less and less in touch with how their results are being generated. And we actually think that this, disclosing exhaustively information about all different use cases creates like a false sense that the user then, can trust any analysis that they perform with a given tool without understanding at all about how the analysis or the results are generated. And so we think that actually is quite harmful. And, perhaps the more relevant issue is the community and also sort of communication between the computational and biological sides, like really placing more emphasis on people being able to properly assess their own results and to understand how their results are generated. And, even if they're primarily experimentalists, to gain enough sort of exposure and fluency that they can really begin to ask questions about, how their data, how the results are generated and how the computational approaches are working. And we just think also with generative AI, this becomes really an increasingly important issue.
I agree.
Oh, wonderful. Thank you. And the pro team, please.
Yeah, so we don't disagree as much as we agree, I think, but that transparency and communication really are the key, but that part of that is researchers being open about what they know about their methods, including what they know about their methods not working. And we really should be holding ourselves to the same standard as everyone else in every other field to test our methods thoroughly and be sure our results are correct before we release them to the world, including where it might not work and showing that it doesn't work when it shouldn't work. And sometimes it does work where it does work. And that this shouldn't be seen as something that takes away from the paper, which I know a lot of people think it does. But that shouldn't be the perspective we take on this, but that this is something that adds to it. Maybe it's not for every reader, but for some readers, this is going to be very important information because it gives us, the field, a way to move forward, right? It gives people a way to improve on your method or develop their own method to fill in the gap that your method doesn't do. So every limitation should not be seen as a problem with your method, but as an opportunity for someone else to improve or develop a new method. And that's how we can really move the field forward as quickly as possible, rather than trying to hide these limitations. And that was all I had for that.
That's all. Thank you. Oh, wonderful. Now we'll take a moment to give the audience an opportunity to vote again on the motion to see if anything has changed after the discussion we have had today. I have just shared the link in the Zoom chat. Okay, I can see the votes are coming in. I'll give a couple more seconds
Yeah, and while the
and then
votes are
pass it off
coming
to
in,
Arpita.
yeah, while the votes are coming in, just a big thank you to all of our speakers and to everyone in the audience really for joining us today. Very rich perspectives. The discussion brought, to light many thoughts or many considerations that I hadn't really thought about when I went and shot off a rant on LinkedIn that day. So I'm very glad to and grateful to have learned so much through this debate. In science, really, the way I've started to think about it is transparency and practicality shouldn't really be opposites. They should be partners. In today's discussion, I think really proves just how powerful that partnership can be. So this debate or this discussion, I just view it exactly, as important in why open and thoughtful discussions drive better science. So yeah, with that, let's see how the audience has voted and find out which side has carried the day. Aliona, do you want to reveal our winners?
Yes, the winner of today's debate is the pro team for the motion. So we did convince the audience that method developers should be required to publish their known limitations and failure cases alongside benchmarking results. But thank you so much for both teams for their opinions. It's hard to argue for both sides, but it also makes us think about all the different ways, all the different arguments that are to one story, because there is something for each side.
I think in the end, all four of us came to the same
Yeah,
middle
everyone was
ground.
arguing.
So I think we're all winners, and I think the community
Yes.
really is the main winner here.
I think Alissa and I, obviously, we agree with everything you push forward. We are proponent of open science. We should always disclose more information. We play that game for the sake of the debate. But I think what the discussion brought is really just the reality. There are a lot of conflicting pressure on the system that may make you behave in a way that is not the best for science. I heard somebody said, like, the current system is good for scientists, not for science. And I feel like it resonates. Obviously, the system is broken. We have to change it in so many ways. And being transparent is at least a good start. It's not enough, but a good start. So I agree. It was fun.
Yeah. Yeah, I think we really need to recognize that science is not the same science it was when it was a handful of stuffy old guys in a couple of universities working away at their desk and hanging out at conferences every now and then. We really need to update our system for the reality of science in the modern world.
And remove some incentives and creating new ones, which will take time. But science is not a business. We do science for science, we should not have other incentives like money or whatnot or career.
So it sounds like drinks are on ban next time, guys.
Absolutely. I just wanted to very quickly add that everyone in the audience should really check out Benjamin's workshops on transparency and reproducibility in science on YouTube. It's an absolutely rich resource. And it's not just Benjamin. I think everyone on our panel has absolutely amazing talks and conference presentations up on YouTube for free. So I really encourage the audience to go check those out and just enjoy the content and the inspiration behind all of their work. So Aliona, do you want to wrap up and just a thank you from my end? And Aliona, do you want to finish off with some closing statements?
I just want to thank again all the participants and the audience as well. We wouldn't have been able to host this debate without you. And thank you to our wonderful moderator, Arpita, whose idea we built the debate upon. I hope this is a very fun format for us to discuss these important topics. We haven't seen a lot of debates in science before, and we're definitely are looking forward to hosting more in the future. So please let us know if there are any topics that you would like us to discuss next time. I have also just shared the link to a Google survey for the audience. Please fill it out because that helps us become better for our next events. And I would also like to thank Shamini, the founder of Panoramics, who also has contributed immensely to organizing this event. And I'll pass it on to her to give some more closing remarks and to wrap it up.
So in the spirit of transparency, I have to say this entire organization was not me, it was Aliona, together with Nicole and Smriti. I cannot take any credit for it. But just to close things, I think everyone came in like already ready to vote for the pro team. That includes me as well. And this is a debate. You're supposed to be at each other's neck, like carpe jugulum. But in the end, jokes aside, I think we raised a few good points here. So in general, I think everyone gets the sense that no one really likes the journals. But I think the important question that we need to ask is, why are they so powerful? Maybe it's because we're giving them too much power. And I think that we can take that power away because the world has really changed, right? We have different ways to talk and communicate with each other. We can address these problems. We see a LinkedIn post, we can change it into a debate, we can call out on such things. And the second thing is, we need to teach and train our students. We need to teach them and train them to use their instincts, their mind, and maybe a bit of, their heart as well, all right, to question and not just get carried away by something that's fancy on the outside, not just about the optics. Now, when it comes to method transparency, which is the focus of this debate, all right, computational or experimental, both should be transparent. I think that IP, trade secrets, and all this should be respected, and that's fine. But I think it's all about, respecting boundaries and yet implementing trust and also comfort. Because at the end of the day, what every one of you kept repeating is that science must have an impact without or with profit or IP. We are, after all, scientists, and what we do has an impact, has a toll on the future and our surroundings, and we need to protect for honesty. And optics can be scary, and that's why we need to have these talks, because I think we need to stand by each other. We need to stand by each other, and we need to support each other when it comes to method transparency. So the take-home message is, are we willing to fight for it? For instance, spatial and AI has a serious transparency issue right now, especially when it comes to sharing negative data, when it comes to sharing architectures. So are we willing to take and do what it needs, and what are the costs that is related to it? So we need to hold ourselves accountable, yes, but I think we also need to hold each other and other companies, other labs accountable as well. So really, really thanks a lot. I felt that everyone united at the end of it. So maybe that was what it was meant to be, to actually realize that we do share a common cause. And so I think this is good progress. Thank you so much for coming. This wouldn't have been possible without you. And yes, we are looking forward to more debates. In fact, we are having a summit next year, Canada's first spatial and single cell biology summit. And we are looking forward to having every one of you there, if possible. Thank you. And I'm going to hand it off to Alissa.
Thank you for the concluding remarks. Here is our pre-registration that I thought I would share as well for the summit taking place in Toronto. Please either follow the link on LinkedIn that we have posted or scan this QR code at the bottom to pre-register for the conference. We're hoping to host a debate at the conference as well. And I think this is a great experience. So thank you all for participating. And yeah, I think we can conclude the event. Thank you for your time and have a great rest of your day.